Okay, so the recording has started, and today we're going to be, this is like day 4 of dynamic programming bootcamp at IIT Gandhinagar, and we've covered 3 lectures so far, 3 very long lectures, and we've covered a lot of basics. We started from the very scratch when it comes to dynamic programming. Now, from this point, we would be moving into much more advanced stuff. Like even when we talk about the CSES problem set, we've basically covered almost 50% of it already. So now the problems that we will be covering from the CSES problem set or from code forces will be a little advanced. Like they won't be of a very introductory level, right? So as far as this session is concerned, there are some prerequisites. Prerequisites include like some knowledge of recursion, and also you should be comfortable in the topics that I've taught so far. All right. So yeah, I mean, let's get started. This is day 4 of dynamic programming. So before going into today's concepts, I would again like to cover some problems from the CSES problem set, and these were also the problems that I had given as homework in yesterday's session. Fine. So let's start with problem number 1, and this was the problem: edit distance. So how many people have already tried out this problem? Uh, I mean, since this was a homework problem, how many of you tried it out on your own? Okay, I see a lot of +1, so this is great. Right, so let's just read the problem statement. The problem statement says that the edit distance between 2 strings is the minimum number of operations required to transform one string into the other. And there are these following operations which are allowed: add one character to the string, remove one character from the string, or replace one character in the string, right? So for example, the edit distance between love and movie is 2, because you can replace L with M and then add I, right? I hope this makes sense. Like you have this LOVE and MOVIE. So you can replace L with what? You can replace L with M, and then you can insert an I in the middle. So the edit distance is 2 because you're performing 2 operations here, right? So first of all, look at the constraints N and M. N is the length of the first string and M is the length of the second string. Both are going up till 5,000. Okay, so you have to find out the edit distance between the given 2 strings, which is the minimum number of operations required to transform either A into B or B into A. Both of them are same, right? So let me just look at the chat once. Okay, fine. So let's take an example. Let's take a different example, something like, yeah, let's say we have A, and C, and we have another string which is B, and let's say you have B and C. So tell me what will be the edit distance between these 2 strings? What do you think? Okay, people are saying 2. How 2? Because first you can look at this A, right? You can look at the first A and you can convert it to what? You can convert it to B. So the string becomes BAC in the first operation. Now you have to convert BAC to BC. So clearly you can remove this character A and it will get converted to BC. So essentially that was like 2 operations, right? So are you guys able to understand what the problem is saying here? Okay, great. So I mean, think about it. Like if I give you, let's say, a string, it is string A, you have the string, and you have the string B. Just look at the very first character of these two. What are the possibilities that you have for the very first character of both of these strings? Let's say there was an A here and there was an A here. So tell me one thing: if if both of these positions contain an A, can we directly move to the next position in both of them and consider that as the actual answer? Basically, like we skip this first character in both of them. Will it harm us in any way ever? Because we're matching characters here, right? So if both the characters at the position that you are at are equal, then it makes sense to just consider both of them. Don't change anything in any of them and move to the next one, right? So let's say you were standing here in this string and you were standing here in this string and you wanted to calculate the edit distance between these 2 strings. You wanted to calculate the edit distance between this string and this string. And now you realize that the first character is same in both of them, A and A. So can I say that the edit distance between the 2 strings that we were considering initially, which was these 2 complete strings, is nothing but the edit distance between these 2 strings now, the part that is left, because the first character we didn't really have to change it in any way. So would that be like a fine thing to say? If the first 2 characters are same, then obviously the edit distance that we're talking about is nothing but the edit distance of the two suffixes that are there in the two strings. Would you ever want to delete this a? If there is an a here and if there is an a here, would you ever want to delete either of them, or would you ever want to replace them? Yeah, we would never want to do that, because here, like, we are matching both of these two characters. It is always in our favor to match character. If they're not matching, then we will have to do some operation, right? If they're already matching, why do we even care about it? So now let's think about the other case. Let's say you are the first character is a and the second character, in the first string, the character is a here, and in the second string, the character is b here. What are the possibilities that you have now? One possibility is to change this a to b, right? That's one possibility. So if you have, let's say, a and, or let's consider it like this, you have a string, the first character is a, and you have another string whose first character is b. So you can combine this and move to another state or another, you can solve a different problem by saying that you convert the first character to a b. Okay, so let's say you convert this to a b and this remains as a b. What happens here? How many operations have you done just to do this thing? You've done just one operation, right? What else can you do? You can convert this b to an a, right? Are these two operations same? Like converting an a to a b or converting this b to an a, are both of them same or not? Yeah, they're same, because essentially whenever they become equal, let's say you converted this a to a b and this b remained the same. If they both become equal, then you will say that, the edit distance is 1 plus the edit distance of these two suffixes, this part remaining and this part remaining, right? So even if you convert this b to an a, then also the equation that you'll get will be the same. Is this making sense? That it is both of them are same, like converting a to b or b to a when you are replacing the character, right? Okay, what is the other possibility? Let's say you decide to delete this b. What happens then? Can you say that the edit distance between these two strings would be nothing but the edit distance from in this string and in this string? If you deleted this b, can we say that? So what will be the equation? We'll say 1 plus the edit distance between these two, because we are removing one b here. Okay, another thing that you can do is do this. Like you have an a here and you have a b here, remove this a. So can I say that then the edit distance will be the edit distance between these two strings? 1 plus these two strings. Can I say that? Okay, what else can you do? Can you also let's just see if we can change both of these strings, or are we allowed to change just one of them? Is the minimum number of operations required to transform one string to the other? The allowed operations are? Yeah, so are we allowed to change both of these two strings? I think we are allowed to change both of them. Okay, fine. Now another operation could be that, there is an a here, there is a b here. Instead of removing anything, add an a here. Can you do this? Add an a here in the starting. Then both of these will match, the first character of the first string and the first character of the second string. So can I say that if I add an a here, then the edit distance will be 1 plus the edit distance between this part and this part? Because now you haven't really removed b, right? You have inserted an a before b. So this b still has to be matched to something else. So is this correct, saying this? That now the edit distance will be 1 plus this thing. Okay, so what are the possibilities? What are the possibilities? The first is match both of the characters. Match both characters. The second is delete from either. When I say match both characters, I'm saying that replace one of the characters to the character in the other string, right? And the third is to insert some character. Insert in either of the strings. So tell me one thing. We saw this, right? That if you have this and if you have this, if we are matching both of them, like if this was a and this was b, if we are replacing this with an a, or we are replacing this first a with a b, they both are same, right? These both operations are same. Like either you replace the b or you replace the a. These are same, right? But what about this part? Deleting from either of them. Can I say that deleting from the first is same as deleting from the second string? Will both of them be the same thing? Like deleting either from the first string or deleting from the second string? No, they won't be same. Similarly, as far as insertion is concerned, what do you think? Will insertion be same in both of them? Are we when we're inserting in the first one or we are inserting in the second one? So this will have two cases: delete from string A or delete from string B. Similarly, insert in string A and insert in string B. But when we're talking about matching both the characters, it's like, either you replace from A or either you replace the character in A or you replace the character in B. Both of them are the same thing, because now we have to move our pointer to the next one, right? So now think about a DP state. What do you think could be a DP state? You have this first string and you have this second string. Okay. So somebody's saying I comma j, but what do you mean by I comma j? You're saying DP of I comma j. That is something that I'm able to understand. DP of I comma j. But what does this represent? No, don't give me a transition. First of all, define what the state means. Index in string 1 and index in string 2. Okay, but what does it mean? You are standing here at the ith point in string 1 and you're standing at the jth point in, let's say, string 2. What does it mean? What you can say is DP of I comma j is equal to the edit distance between these two suffixes. Right, I can say this. The edit distance between these two suffixes. I can say this, right? DP of I comma j. Can I say this? Yeah, you can also say that DP of ij is equal to the minimum, the edit distance between these two strings, this and this. But the suffix and prefix words would be like kind of the same thing only. When you're saying the edit distance is the distance between these two strings, the prefixes, or you're saying that DP of I comma j is the edit distance between the suffixes, they both are like valid states. You guys get this, right? That both of them are valid states. Either you consider the prefix or you consider the suffix. Fine. Okay, now let's formally define our DP state. And we are considering the suffix for now. Okay. So you say DP of I comma j is equal to minimum or basically edit distance between string A starting from I to n and B starting from j to m. Is this a fine DP state? Okay, perfect. Now tell me, what are the cases? Let's say the first case is, the characters that you're standing at are both equal. If A of I equals to B of j, what happens here? Can I say DP of ij is nothing but you shift both of these parameters by 1 is equal to DP of I plus 1 comma j plus 1. What is happening here? When we are standing, you have two strings. You're standing at the ith character here and you're standing at the jth character here. If they both are same, we'll just say that, if the edit distance was to calculate between these two strings, between these two strings, this one and this one. Now, instead of calculating between these two strings, just calculate between this blue line, these two blue lines, like one character ahead. And they both are same, so we don't have to perform any operation. Okay, perfect. Now, the case was this, if they both are not same. Else, what are the cases that we have? The first case is insert in string A. What happens here? Here, the ith character and the jth character are not same. So what I am saying is that insert the, like this is B of j, and this is A of I. So before A of I, just insert a B of j. Before this character, if I insert a B of j, can I match this B of j with this one? Like if this was, let's say, a C here, and this was, let's say, a D here. So before D, you insert a C. So now I can match a C with a C. So what will be a DP state now? What will be the two strings that will be left? We are moving the J pointer one ahead. Why? Because we have matched this C with this C. But have we moved the I pointer ahead? Have we moved the I pointer ahead? Or have we just inserted something before the I pointer? Yeah, we've just inserted, right? So insert in string A would mean dp of I comma j is equal to 1 plus, okay, you performed some operation here. So 1 plus I comma j plus 1. And insert in string B. What happens here? Then you say dp of I comma j is equal to 1 plus dp of I plus 1 comma j. Because now you're inserting at the jth character in B, but you have to match it with the ith character in A. So you match this part, like if you're inserting before here, you match this part with this D. So now you increase your I pointer by 1, but you keep the j pointer at the same location. So are these two things clear? Like insert in string A or insert in string B? Okay, what about delete in string A? What happens here? Like if you delete this part, what can I say? Can I say that this character is gone? So now you find the edit distance between these two parts. This part and this part. Can I say this? Yeah. So what will this be? This will be dp of I comma j is equal to 1 plus dp of, what have we done? We've moved the I pointer ahead by 1 because we've removed the ith character. Else delete in string B, which is dp of I comma j is equal to 1 plus dp of I comma j plus 1. Okay, tell me one thing. Aren't these two things same? Like deleting in string B or inserting in string A? So can I say that it is actually like in this case, in the else part, this is nothing but dp of I comma j is equal to minimum of, 1 plus minimum of dp of I comma j plus 1 comma dp of I plus 1 comma j. Is this the right transition? If they're same, then I say dp of I comma j is equal to dp of I plus 1 comma j plus 1. Otherwise, I say this. Okay, perfect. Now, what about the base case? Let's say I'm standing here at the end. I'm standing at the end, or let's say I've already crossed the string A and I'm standing here in this part. What can I do? Either I can insert all of these characters at the end of string A, or I can remove all of them. And can you see that both of these operations are pretty much the same? Like let's say your ith pointer is now is here. You've already crossed the string string A, but you're standing at this point in string B. So aren't these two the same thing? Either you insert all these characters at the back of string A, or you remove all these characters from string B. They will require the same number of operations, right? So I can say dp of n comma j. If you are standing at n comma j, n being the end of the string A, is equal to nothing but m minus j. If you are standing at the jth character and the length of this is m, I will have to remove m minus j character from here, right? Or we have dp of I comma m is equal to n minus I. These are the two base cases that you have. Either you're standing at the end of string A, or you're standing at the end of string B. Is this clear to everyone? Base case. Okay, what is the final subproblem? Look at the state. Edit distance between string A of I to n and B of j to m. And the problem asks you for exactly what? The complete string. So can I say the final subproblem is dp of 0, 0? Okay, perfect. So a lot of people have written the right answer. Okay, one more thing. The problem is solved. You have to just code it up on your own. I'm not going to code it up. But before that, tell me if this was a difficult problem or was this like kind of easy? Okay, good. Good that you're finding it easy. Yeah. So let's just put it on the slide. The transition is this. I can put this transition in this way. So if A of I equals to B of J, then it is dp of I plus 1 comma j plus 1. Otherwise, it is 1 plus minimum of this. Is this thing right? Sorry. This is like a ternary operator. So if these characters are same, then I say this. Otherwise, I say this. right? I hope this is fine. Okay. What about the base case? Base case is nothing but dp of n comma j is equal to m minus j, and dp of I comma m is equal to n minus I. Final sub problem is dp of 0 comma 0. So this problem is done. Okay. Can we move to the next problem now? Okay, great. Let's solve this problem now. So this problem says that you have a rectangle of A cross B, and your task is to cut it into square. On each move, you can select a rectangle and cut it into two rectangles in such a way that all sides remain integers. What is the minimum possible number of moves? So the problem goes like this, that if let's say you had, okay, let's consider the sample case that is given to us, sample test case. A is 3 and B is 5. So this is 3, comma, yeah, this is 5. So let's make it bigger. This is the rectangle that you have. You have to break it into squares. So one such square could be like this, 2 cross 2. As soon as this rectangle breaks into 2 cross 2, you can say that in order to, you don't have to break the square further. Is this clear? Like you have a rectangle, you have to make some square pieces out of it. But basically, if let's say you have 2 cross 2, you don't have to break it further. You don't have to convert squares of, you don't have to make squares of size 1 cross 1. Even if you have a square of size 3 cross 3, that is a good enough square. Like you don't have to break it further. Fine. So they're asking you for the minimum number of moves that you will have to perform. Okay. Let's try to do some moves and see what are the things that you're creating. So for a given rectangle, you can make one move in it and you can cut it. You can cut it either along the x-axis or along the y-axis. Let's try to cut this rectangle along the y-axis. Let's say somewhere here. Let's say we cut it here. Okay, don't give me the DP state or the transition just yet. First of all, try to understand what we're doing. Let's say I try to cut this rectangle here. What are the two rectangles that I will get? Give me the dimensions of the two rectangles that I will get. This is
sorry, Priyansh, I think the comment in the chat was about the previous problem. Can you take a look?
Oh, sure. So you're saying dp of ij should be minimum of, it should be 1 plus minimum of I plus 1 comma j and minimum of I comma j plus 1, and as we have to do 3 cases. Yeah, we have to do 3 cases. So let's see what are the 3 cases. The first case is when they both are same, like a of I is equal to b of j. What happens in that case? Do we need to perform any operation if they both are same? Talking about this problem, if let's say you're standing, these are the two strings, you're standing here, this is let's say equal to a, and this is, you're standing here and it is equal to a. So can we say that, we don't have to perform any operation when they both are same? We can just move both the pointers ahead, the ith pointer and the jth pointer. So is that clear? If they both are same? Okay, so that's what we've done. If they both are same, then I say that you directly move both the pointers by 1, and you don't add anything to your edit distance. But now we had this thing. Let's say we insert in string a. Okay, first of all, what is not clear exactly? You are saying that shouldn't it be 1 plus minimum of dp of I plus 1j, comma, minimum of dp of ij plus 1 and I plus 1? No, you're performing an operation every time, but should we be performing an operation every time? Yeah, you're adding 1 every time, but we shouldn't be doing that. We should only be adding 1 when we are inserting or we are deleting some character. Oh, I got it. So what we did not do was this part. So we talked about these 4 operations: insert in string A, insert in string B, delete in string A, and delete in string B. But we did not talk about this thing that what you can do, you can replace the ith character in string A with the jth character in string B. So this is something that we missed. This is actually right. Replace in either string A or B. If we do something like this, then we have dp of I comma j is equal to 1 plus dp of I plus 1 comma j plus 1. So yeah, that's right actually. So now is this clear? Can we move to the next problem? Yes. Okay. So let's say we have a rectangle. We have 2 sides. We have 2 sides. Let's say we have 2 sides. So let's say we have 2 sides. So now is this clear? we have three type of operations when they're not equal. Either we insert or we delete or we replace. So I actually forgot about this part. Yeah, it's actually important. So it should be nothing but, I mean, taking the minimum of all of these, I plus 1, comma, j plus. Let me put that there. Thanks for adding that. Okay, so you're saying, but it will give us wrong because one delete and one insert is equal to one replace. No, that's not right. If you look at, okay, I think, yeah, it's not like one insertion and one removal will make a replace. You can directly replace one character with this operation. So if you have, let's say, an A here and a B here, you can directly replace this A with a B, and now they both match. So you can increase both the pointers ahead. Right, cool. So yeah, thank you so much for adding that. I had actually missed it. So now I think this should be clear. Like if they both are same, then you don't have to do anything. Move both the pointers. If they both are not same, then you have to perform at least one operation. Now this operation that you're performing could be of three types. It's actually of five types if you look at it. It's actually of five types, but two of them are same as the other two. So overall, it's kind of three operations only. Right. Perfect. Thanks for adding that. Let's move to this problem, which was rectangle cutting, and I was talking about this example. So if you have 3 cross 5, and if I, let's say, cut across this axis, so what are the two rectangles that I will get after doing something like this? If I have 3 cross 5, what are the two rectangles that I will get? Give me the dimensions of that. If I cut across this axis, this green line is the actual cut. Okay, somebody saying 3 cross 2. So you have this 3 here, and 2. Right, this is 2. And this is 3. And this is 3. So the two rectangles that you'll get are 3 cross 2 and 3 cross 3. Tell me one thing, is 3 cross 3 a square? Is 3 cross 3 a square? So do we need to perform any more operations in this square to reduce it further? Yeah, it is also a rectangle, but our problem statement is this, that you have to break this entire big rectangle into squares by making some cuts. So if I talk about this rectangle, this is actually a square. So do I need to make any more cuts in this square to reduce it further? It's already a square, right? So can I say that this we don't have to really consider now, this is gone. And how many operations have we performed already? We have just performed one operation. So what is the remaining rectangle that I have? The remaining rectangle is this 3 cross 2. Okay. Now what I can do is I can make a cut here. Right? Can I make a cut here? This is 3 cross 2. What happens when I do that? What are the two rectangles that I will get if I make a cut along this side? I will get 2 cross 2 and 1 cross 2. That's correct. So is 2 cross 2 a square? Can I neglect it now? Yeah, this is gone now. So what do I have remaining? I have this 1 cross 2 remaining. So what is the only cut that is allowed now? I can only make this cut. So what are the two rectangles that I will get? I will get 1 cross 1 and 1 cross 1. So can I say now both of them are squares? So how many operations did you make in total? How many cuts did you have to make in total? 3 cuts. Okay, let's consider one more possibility, and you'll see that in this possibility, we are making more cuts. Let's say instead of making, if I have this part, let's say we were having 3 cross 2. Instead of making this cut, I made, instead of making this cut, let's say I made this cut. What are the two rectangles that I will have? I have 1 cross 3, 3 cross 1 in each of them. So I have this one rectangle, 3 cross 1. And I have another rectangle, which is 3 cross 1 again. Okay, so now we need to solve this independently and solve this independently, because we can make a cut in just one rectangle. So how many operations do you need to convert this to squares? How many cuts that you will have to make to convert this to a square, this to all squares? 3 cuts. No, you will just have to perform 2 cuts, 1 cut here and 1 cut here. Yeah. So in order to convert this, you have 2 cuts. In order to convert this, you have another 2 cuts. And in order to, you made 1 cut here. And you had also made one cut when you were converting that 3 cross 5 to 3 cross 2. So how many total operations did we make now? We have two, we have one, and we also made one operation at the start. Yeah, in total we made 6 operations. But can you see in the previous, in our previous approach, we were making just 3 cuts. So which was better, the approach 1 or the approach 2? Approach 1 was better. So you guys get the idea of the problem, right? Like what exactly is the problem? What is it asking you? You have to continue making cuts, and once you make a cut, the two parts separate out. Basically, if you made a cut, the two parts that are coming up now, they're separate. You will have to solve them independently, and you will have to add their operations. Fine, you cannot make one cut which is crossing 2 rectangles. You can make a cut in just one rectangle. Right. So now tell me, think of some approaches. You have an entire rectangle in front of you. How do you break it into squares? Let's say I give you an n cross m rectangle. What do? First things first, if let's say n is equal to n is equal to m, what does this mean? This means that this is already a square. So do you have to make any cut here? Yeah. For this case, the answer is 0. Perfect. Now think about it. How do you solve it using DP? Think of smaller subproblems. This is a big problem. What could be some smaller subproblems? Think of smaller subproblems. Okay, Aman is saying make a cut of size minimum of m cross n into minimum of m cross n every time. Okay, I don't understand what is that. What do you mean by that? Yeah, I'm giving you 1 to 2 minutes to think. Don't worry about that. So think about it. But I'm not able to understand what you're saying here. Make cut of size minimum of m cross m comma n into minimum of m comma n. What is that?
Yeah, like basically we have been given 2 dimension m and n. So every time we will make a square of size which is minimum. Like n is 2 and m is 3. So we will cut 2 cross 2 and we'll update m and n. The next time when we go and the smaller the dimension, we will cut for that dimension only.
Okay. So what you're saying is that if you have m cross n, let's say this is n and this is m, so you make a cut of the smaller dimension. This is what you're saying. So let's say you break out this part. This is n into n. You break out this part and you performed one operation here, but this became a square. So now you solve for this part. This is what you're saying, right?
Yes. Yes.
Okay, but is that a DP approach or is that a greedy approach?
This one is greedy approach.
Yeah, this would be a greedy approach. Let's try to see if it works or not. Let's try to make some cases where it can fail. But yeah, that's a good start actually. Like you could think of a greedy solution as well. So let's say I have something like yeah, let's say this is 3 and this is 4. We have this part. Okay. 3 cross 4. 3 this side and 4 this side. So if you what you were doing was this, you make a cut here, right?
Yes.
Okay, so that will be one operation, but this entire thing will become a square. And then you have a block of size what? You have a block of size 3 cross 1. So how many operations did you perform in total here? You have to perform 2 operations here.
Yeah.
2 operations here and 1 operation here, right?
Yes, overall 3 operations.
Overall 3 operations. Can we do it in less than 3 operations? That's the question. Let's see. I think we cannot do it in less than 3 operations for sure.
Yeah, for this case, it won't be possible in less than 3 operations.
What if this was, let's say, 3 comma 6? Yeah, then though if you make a cut here, then it is already, both of them are already squares. So that would be a good cut in that case. Okay. Fine. Can anybody think of cases here which will not work when we do something like this? Although this seems like a good approach. Let's say you had 3,7. 6 cross 5. 6 cross 5, this will not work. Okay, somebody thinks of n is large, then very high number of cuts. What about 6 cross 5? Yeah, let's see. You have 6 here and you have 5 here.
Yeah, sir.
Yep.
So if we take like n cross n plus 1 rectangle, so in one step we'll remove the n cross n square, and then it will take n more steps to remove or
n minus 1 more steps. Yeah.
no.
Yeah, actually n steps. So what you're saying is this, that if you have n cross n plus 1,
Yes,
so first you will remove a block of size n cross n, and then you will be left with 1 cross n plus 1. So now in order to remove
n more steps.
Yeah, this is 1 plus n steps in total.
So if n is very large, then this greedy approach won't work. Maybe.
No, but how do you know that your DP solution will give a solution less than 1 plus n? Let's see 6 cross 5. Okay, I had already drawn that, right? Yeah. So think about some better cases, like better cuts that you can make. Let's say you make a cut here. Okay, so by the approach that the first person had suggested, this would take how many steps? This would take 6 steps, right? Because first you will break it into 5 cross 5 and then 1 cross 6 will be left. So for 1 cross 6, you will require 5 more steps. That's like 6 steps in total. But what if you make a cut here? What happens here? So you will be left with, 6 cross 3, and you will be left with what?
6 cross 2.
6 cross 2. Okay, so perfect. I think we found an example. So for the first case, you were taking 6 operations. Can you convert the 6 cross 3 into squares in just 1 cut? This will be left, so you make a cut here, right? So you get 1 step here. And what about this? Can you convert this into 2 cross 2s in just 2 steps? So this was there, you cut here and you cut here. So you get 2 steps here. So in total, how many steps did you make? You made just 4 steps.
4.
You made the first cut and then you made these cuts. So can you see that the greedy approach will not work in all the cases?
Yes.
Okay, perfect. But that was a good thought, actually. Right. So now since we're done proving that the greedy approach won't work, what are the solutions that you guys have in mind now? I had seen one DP state written. Okay, so Raj has suggested DP of I, j is the minimum number of operations to cut a rectangle starting at 0, 0 and ending at I, j. Or what you can say is DP of I, j is steps required to cut a rectangle of size I cross j. Rectangle of size I cross j. How many minimum steps will you have to perform to convert a rectangle of I cross j to square? Can we make this as a DP state? Okay, so actually that's a good enough state. But now let's talk about what are the possibilities. Let's say you have I cross j. This is I, and this is j. How many possible cuts do you have? First of all, tell me this. If we talk about making cuts along the row, what happens then? How many cuts do you have possible? If the length is I, how many cuts are possible? You have I minus 1 cuts possible. Yeah. So first possibility is like I minus 1 cuts along the row. And if you talk about along the column, how many cuts do you have? J minus 1. If you cut along the row, along the column, you have J minus 1 cuts available. So tell me one thing. if you have dp of I comma j, you want to find out the minimum steps to convert this rectangle into squares. Let's say you make a cut at this step. This is, let's say, I cross k. What will this dimension be? This will be j minus k, right? If I make a cut here, then I will divide this rectangle into two parts. What are the dimensions of that two parts? If let's say the dimension that you're cutting at is k, then you have I cross k, and you have I cross j minus k. Is that right? The two rectangles that you'll get? Right. So can I say that if I talk about cutting along the column, can I say dp of I comma j is equal to 1 plus, because you're making a cut here, and now you will consider all the possibilities. Every time you make a cut, you get two rectangles. So if you get two rectangles, what will you do? You will add the operations required for both of these rectangles, right? If you convert your current rectangle into two rectangles, now you have to convert those two rectangles into squares. So you will add both of their operations. So what you can say is this: minimum of dp of I comma k plus dp of I comma j minus k, spreading across all k's. So k starting from 1 to what? 1 to j minus 1, right? Is this right? When you're making the cut along the column. Okay, what if you're making the cut along the row? This will be 1 plus minimum of dp of k comma j plus dp of I minus k comma j. And again, k going from 1 to I minus 1. Is this right? Okay, perfect. So let's just write it on Sublime. You have dp of I comma j is equal to minimum steps. It should be minimum of these two. Yeah, so we will take minimum of these two, like minimum of this part and this part. Yeah, that's correct. So minimum cuts to make a rectangle of I cross j into squares, right? The transition is what? dp of I comma j is first of all equal to 1 plus minimum of dp of I comma k plus dp of I comma j minus k. This is when you're making the cut along the column, right? And the other thing is 1 plus minimum of dp of k comma plus dp of I minus k comma j, right? So we'll take the minimum of both of these two. Is this fine? Base case, dp of I comma I is equal to 0. When you are already standing at a square, that is you don't have to make any other cuts. And the final subproblem, dp of n cross m, dp of n comma m. Yeah, that's right. Okay, can you guys code this problem on your own, like either recursively or iteratively? Okay, great. So let's just copy this part and put it on the slides. The base case is dp of I comma I is equal to 0. Final subproblem is dp of n comma n. Okay, so is this problem fine? Like any doubts in this? This rectangle problem? Also, I think now we are moving a little fast, like we're able to come up with states faster, and we're able to do these transition things faster. Also, the base case and final sub problems are coming up much faster. This problem was realized that it is a DP problem. But on first glance in contest, if you see this problem, how can you identify whether it is DP or greedy? So that's a good question actually. And this is something that I will be talking about in the next lecture. When we are done talking about almost all the concepts, I will give you one trick to identify whether it is a DP or a greedy problem. Right? So right now, I'm not going to give you that trick, because if I give you that trick, every other problem that I talk about from this point, you will directly tell me that this is a DP problem and you will not go into that greedy direction. But I want you to go into that greedy direction and prove yourself wrong there. Fine. So we'll talk about this part, like this trick, in the next class. Don't worry about it. Okay, great. So let's talk about this third problem. And then after that, I'll talk about the concepts that I wanted to cover today. So this problem says that you have n coins with certain values. Your task is to find out all money sums you can create using these coins. And I think you cannot use a coin 2 times, or I mean the same coin more than once. Because if you can use the same coin more than once, this will be like infinite number of sums that you can make. So this is basically asking you to find out all the values of money sums that you can create with some subset of the coins that you pick up. Is this making sense? This problem? You have certain denominations. You have some coins of certain denomination. You have to pick up a subset of these coins and you have to make a money sum. Now you have to tell me what are the money sums that are possible in total. Okay, one thing. How many total subsets are there for an array of size n? 2 to the power n. So are all the 2 to the power n, are we going to have 2 to the power n distinct money sums? That's the question. Look at the constraints on xi and n. Xi being what? Xi being the denomination of the coin. So what is the highest value of money sum that you can have? If let's say all the values given in the coins are of value 1000, what is the highest value that you can create then? Can you create 2 to the power n, like 2 to the power 100 as your value? You cannot. But if I tell you that all the denominations xi are equal to 1000, and n is the number of coins which is equal to 100. This is the constraints. These are the constraints that are given to you in the problem. So what is the highest value that you can make if you're considering some subset and you're adding all the values? Consider the entire subset, like the subset of all the coins, and what will that be? That will be 1000 into 100. So what is the maximum value of coin that is maximum value of money sum that is possible? 10 to the power 5. Great. So is 2 to the power 100 bigger, or is 10 to the power 5 bigger? What is bigger? 2 to the power 100 is much bigger. So now we know that the actual distinct money sums that are possible are how many? 10 to the power 5. So I hope this observation is clear to everyone, that the maximum value of the money sum that you can make is actually 10 to the power 5. You cannot have a higher value than that. Right? Okay, so now think about this problem. Okay, tell me one thing. If I tell you that the money sums that you can create are 5, 7, 6, or let's keep it like this: 5, 6, 9. What else? You can create, let's say, 10 as well, and you can create 20. Let's say if I give you a coin of denomination 5, what are some other coins or some other money sums that you can make from this set of money sums? Let's remove some of them, because now then you cannot write all of this in the chat. So let's say I had 5, 6, and 9, and I give you a coin of denomination, let's say 4. So what are the other money sums that you can make from this? From this 5, 6, and 9. Yeah, add 4 to each of them, right? Let's say 10 was also possible here. So what are the money sums that are possible now? You can, or let's not keep 10. You can have 5, 6, 9. So if you add 4 to 5, okay, first of all, the possibility is to not add this 4 to any of them, right? If you don't include this denomination in the actual subset, what will the subset look like? I mean, what are the money sums that you can create? 5, 6, 9, when you're not adding anything. Let's say now you add 4 to 5. What will you get? You will get a 9, but is 9 already available? Yeah, 9 is already available. So adding 4 to 5 will not do us any good. What about adding 4 to 6? What will you get now? You will get a 10. But 10 is a new money sum that you've created, so you add here. Now, similarly, if you add 4 to 9, can you get 13? So tell me one thing, if I already give you the set or the subset of, actually the set of money sums that are possible, and I give you a new denomination, what do you do with that new denomination to construct the next set? For every number, you go to every number and you check for 2 possibilities. Either you add that coin to that or you don't add it. That are the 2 possibilities, right? For every money sum. Perfect. So what do? You have a set, okay? You go and add 4 to 5 and you say add 9 to the set, but you realize that 9 is already present, so I don't add it again. Similarly, you go to 6 and you add that, you add 4 to 6 and you check whether 10 is available. You see that 10 is not available, so you add it into the set of money sums. Okay, tell me one thing, can you add 4 to this now and create 14? Can you add 4 to 10 and create 14? No, because that would not be a subset. You would be repeating this 4 again, because this is like a new denomination. You can only add it once. Perfect. So you have to see that this is like kind of the previous state that you had, and this is kind of the new state. Does this ring some bells? Any hints that you've gotten so far when I told you this thing?
Sir, should we also include the case of only 4?
That is correct. That is actually correct. So for that, I should have told you that 0 is also possible, right? Initially, when you don't have anything, when you don't add any money sum or you don't add any coins, what is the sum that is possible? When you don't have anything, what is the only sum that is possible? 0. So 0 will always be possible. So whenever you are saying that you have a set of money sums, when I told you 5, 6, 9, and that's actually a very good question. You should always consider the 0 because you can add 4 independently. So yeah, that's a good point, and you will also get another 4 here. Is this making sense, guys? That when I give you a set, you should also include 0 into it. After this set, should I include a 0 again into this set? Because 0 is still possible, right? Yeah, perfect. So fine. What do you think now? How will you approach this now? When I tell you this, when I give you this hint. Should we write state? Yeah, you can think of a state as well. Let's say I tell you that, okay, you give me a state. I will not give you a state here. Because if I give you the state, the problem would be, the solution would be out. dp of ij being the number of ways to create. Number of ways. Do you need the number of ways? The first question is this. Do you need the number of ways? Okay, somebody has said dp of I is equal to all possible sums using coins up to I. That's a good state. That's a very good state. So what about dp of 0? Like if you're, okay, let's consider one-based indexing for now. You have coins 1 to n. What is dp of 0? What are the money sums possible when you have dp of 0, when you're not using any coin? It is 0. Okay, this is 0. Now you come to this coin. This is what? Let's say this is 10. So what is dp of 1? Okay, so Raj is saying that when I was saying number of ways to create some j using ith coin. Okay, so Raj, one thing, the state that you're talking about, you're saying number of ways. So the very first thing is that you don't really have to consider number of ways. So the state that you might be thinking of could be right. It could be right, but do we need that information? Do we need the number of ways, or do we just need the possibility? So if we just need the possibility, then finding the number of ways is nothing but just complicating the entire problem, right? So what about dp of 1 here? Will it be just 10 or will it be 10, 0? You had this 10, you check for, you check for adding and you check for not adding. So what will be dp of 1? Yeah. So what do you think? dp of 1 will be just 10 or 10, 0? Somebody is asking difference between possibilities and I am not saying possibilities. I am saying possibility. The problem is this. Let's say I give you a grade, okay? You have some traps here. You want to go from top left to bottom right, and I tell you check whether there is a path. This is a possibility. Check for a possibility, not the number of possibilities. Check for a possibility. The other question could be find the number of ways to go from top left to bottom right. That would be number of ways. I am not saying possibilities, I am saying possibility. You guys remember that first lecture? I talked about that thing, right? That there are 5 types of DP problems. One of them is for checking a possibility. I was not saying checking the number of possibilities, but checking for a possibility. Yeah. So the point here is, I mean, right now, if let's say that a DP state is like this, DP of I being the number of, the money sums that you can create, considering the coins from 0 to I. So tell me one thing, what will be DP of 1 if this coin was 10 here? Will it be 10 or will it be 10, 0? What are the money sums that are possible? 10, 0, perfect. Let's say here you have a 2. So what will be DP of 2? Or let's say this was actually a 3. What will be DP of 3? DP of 2 now? You go to both 10 and 0 and you try for checking. You try for adding and not adding. So what will you get? For 0, first of all, you have 0, then you have 10. Then you go and add 3 to 0, you'll get 3. And then you'll get 13. Okay. Let's say there was another 3. So what will be DP of 3? You have 0, you have 10, you have 3, and you have 13. So you go to 0 and you check whether adding a 3 would make one more money sum, and you realize that it will not. Similarly, you go to 10, you realize that again you don't get anything. You go to 3 and you check whether adding 3 would make another money sum, you get 6. Then you go for 13, you get 16. So does this seem like a good state? DP of I being the money sum that you can create from coins from 1 to I. Does this seem like a good state? Sounds good, okay. Talk about the time complexity of this. How many money sums are possible in total? If I talk about the worst case, how many money sums are possible in total? 10 to the power 5. So for every state, how many checkings will I have to do? Like how many additions or not additions will I have to do in worst case for every state? 10 to the power 5 only, right? If the number of money sums possible are 10 to the power 5, then for any state, when I'm checking for either adding that coin or not, I will have to do 10 to the power 5 check, not more than that. So can I say n into 10 to the power 5 will be the time complexity of this? N being the number of coins. Okay, what is n? N is actually 100 here. So the total time complexity or the total number of operations would be 10 to the power 7. Would that be a right statement? Okay. What about the space complexity? First of all, you look at dp of 0. You stored this money sum. Yeah, then you went for dp of 1, then you stored this money sum. Then you went for dp of 2, and then you stored this money sum. My question is, for every state, how much information are you storing? You are storing at max 10 to the power 5 at max 10 to the power 5 money sums, right? For every state. Is this right or not? That for every state you are storing 10 to the power 5 money sums. Okay, you're saying n log n will be the space complexity. How n log n? How is the concept of log n coming into picture? How are you even thinking about log n? Double होते जा रहा है. Double होते तो जा रहा है, but in order to reach 10 to the power 5 money sums, how many doubling operations will you require? Like if let's say you had a money sum, I mean, you had just one, or you had just one number in your money sums set. Okay. So how many steps will it take to reach 10 to the power 5 if you're doubling at every step? If you're doubling the number of money sums, how many steps will it take to reach 10 to the power 5? Log n. What is log of 10 to the power 5? It is roughly 18. Okay. So do you realize that after just 18 steps, your money sum array or your money sum set will have 10 to the power 5 integers? After just 18 steps, if you're doubling every time. And how many steps do you have in total? You have actually 100 steps because you have 100 coins to consider, right? So for the first 18, we can say that we are not reaching 10 to the power 5. But can we say that after 18, most probably we would have reached 10 to the power 5? In the worst case. So can I say that the number of states or the number of basically the space complexity for storing every state is actually 10 to the power 5. Like 10 to the power 5 money sums will have to be stored in every state on an average. For every dp of I, in the worst case, you will be storing how much? You will be storing a money sum set, right? So in this money sum set, how many elements can come in the worst case? 10 to the power 5. So can I say the space complexity is state, or basically n into 10 to the power 5? Can I say this? Okay, tell me one thing. Do I need to that's again like space optimization? Okay, if I'm saying dp of 0, to evaluate dp of let's say 1, and then to evaluate dp of 2. To evaluate dp of 2, do I need dp of 0? I have a money sum set here. So do I need a set for, I mean, do I need dp of 0 set? We don't need it, right? So can we do space optimization here? We can neglect this money sum set of the previous state. We can do that, right? When we're evaluating dp of I, what do we need? We need the set of dp of I minus 1. For all the money sums that are possible in the set of dp of I minus 1, we'll try for adding and not adding. But do we need dp of I minus 2 to evaluate dp of I? That's the first question. And the answer is no, we don't need it. Now I'll give you a much better way to implement it. We don't need to store these money sum set for every case. Let's say I have a global, vector boolean possible. Let's say I say that there are 1e5 plus 1, and I say all of them are false. Like this is the set of money sums that are possible. Okay, I am making a vector which says these are the money sums that are possible, And how many integers do I have in it? I have 0 to 1e5, which is 10 to the power 5 integers in it. So before we even start, what is possible? Before we even start considering any denomination, what is that one value that is always possible? Possible of 0 is equal to true. Now what I will do is I will iterate on all the coins. And I will say, I will create a vector Boolean temp is equal to 1. What am I doing here? I am trying to calculate the next state or the current state basically. So what I will do is I will iterate on all the possible values. So I will say int j is equal to 0, j is less than equal to 1e5, j plus plus. What will I do here? I will say if possible of j. What does this mean? This means that in the previous DP state, this was possible. This jth integer, this j value was possible. So what are the two things that I can do with my current denomination? So let's say current is equal to coins of I minus 1 basically. What are the two possibilities that I have now? Either to add or to not add. So I will say possible of j plus, sorry, I will say temp, because temp is like kind of the new money sum set. I will say j plus current denomination is equal to true. But will I not say temp of j is also equal to true? Temp is our current money sum set, okay? And this possible was the previous one. So when we are evaluating DP of, let's say, when we are evaluating DP of I, this temp is actually equal to DP of I, and possible is equal to DP of I minus 1. I am iterating on all the values that are actually possible, and then I'm trying to add it or not add it. So is this making sense to all of you? What I'm doing here? And then after that, I can just update my possible to the temp, because now this is the new state. And after that, what I'll do for the actual answer, I'll just go from 1 to 1e5. And I will say if possible. Is this correct? This possible is telling me the current, or I mean the previous money sum set. And this temp is kind of the current one. So I can say current here. Is this correct or not? Okay, great. So did we actually write the state here? What was the state? We can put it here. 1 minute. Yeah. Okay, what is the base case? The base case is that DP of 0 is actually this. This base case we've already defined here. Because even before we start, then 0 is already possible. So what is the final problem? Final problem will be DP of N. That will be the final money sum set that is possible by considering all the coins from 0 to I. So is this correct, guys? Is this making sense? And let me also like paste the code here, because this code is not like a very, I mean, it's kind of really the most optimal one. So let me just paste it here so that you have some idea. Because did you see that we did not use any set, we did not use any vector, like we did not have any login operations as well. No hashing, nothing. Everything is working fine in this one. Yeah, so this will come with practice, don't worry. But I think this logic should be clear to all of you. Like the space optimization concept possible, I mean the previous state and the current state. We always evaluate our current state based on the previous state, and then we update our previous state to the current state in the space optimization concept, right? We have two types of state: the previous state and our current state.
Sir,
Yes, go on.
sir, in the if condition, if possible of, sir, like won't we also add the cases where only the current denomination is taken? Like current of current denomination equal to true.
That's actually correct. But what about this? Will j is equal to 0 be always possible? Will possible of 0 be always true?
Right. So it is
If
already.
it is true, then yeah, that's already considered. Okay, perfect. Any other questions that you guys have? But yeah, I was talking about this thing, that in the space optimization concept, there is just one way to solve it. You have a previous state and you have your current state. You first of all update your current state with respect to the previous state. And then once you're done doing this, you just say that previous is equal to current. So that the next time when you're using the next time when you require the previous state, it is actually the updated previous state. This is exactly what you've done here. This possible is kind of the previous state. So we updated our current state looking at the values in the previous state. And then at the end, we said previous is equal to current. So I hope this is fine. Okay. So yeah, let's talk about this amazing concept of answer construction now. Do we have any other doubts as such? Can we move ahead? Okay, I don't see. Okay, yeah, now I see some yes, right. So let's talk about this concept of answer construction. So we talked about this thing, right? We had a grid. We wanted to go from the top left to the bottom right, and I'm going to be using this example a lot of times, this grid example, because this like fits into a lot of problems. So let's say I tell you that you have to go from top left to the bottom right. And what was the question? You had to find the path which minimizes the sum of values encountered. Do you remember that question? Like going from the top left to the bottom right such that the values that you encounter, the sum of them is minimized. But do you guys remember that in the problem, we were only finding the actual value? Did we retrieve that minimum path? Did we actually get that minimum path that was the actual path? Or did we just get the value? The actual path or the value? We only got the value. We never got the path. But in real life, is it required to get the actual path as well? Or are we just satisfied with the value? We do require the path. And it's not like just in real life, you will see a lot of problems as well, where you will have to find out that subset. Like if let's say the problem is to find out a subset which is having a minimum certain value, it would also be like you will have to find out that subset, not just the value. Fine. So how do you solve this now? What do you think? How do you get the path? Once you get the value, how do you get the path? Any ideas, any guesses? Okay, somebody saying going back to n comma m, going back from n comma m to 0 comma 0 by checking upright. That's right. From the answer box, navigate to previous box. Okay. Backtrack from the last state. Okay. Yeah, you guys are close. I mean, you guys are getting some idea. Like we generate LCS. Okay. What is LCS? Have we talked about LCS so far? No, so don't talk about it. We can store whether we took right or down at dpij. That's correct. Okay, remember this. When I said that, dp of ij is equal to minimum sum to go from I comma j to n minus 1 comma m minus 1. This was my state, right? So tell me one thing, when I'm just storing the minimum sum to go from I comma j to n minus 1 comma m minus 1, am I anywhere storing which was the direction that I took to minimize the sum? I have two directions. When I'm standing here, I can either go here or I can go here. So when we were finding the state, did we ever store what was the direction that we took? We were considering the minimum of these two, but did we ever store the direction? We never stored the direction. But is it important to store the direction that we actually took? Is it important or is it not important? It is actually important. The point is, if you ever have to, okay, one more thing. When you're talking about this path construction problem or this answer construction problem, my question is, does this follow in this type of a problem? Find the number of ways. If the problem statement says find the number of ways, then like would this be ever useful to construct that path or to construct those number of ways? It would not be useful, because if let's say I tell you about this grid, going from here to here is like just a huge number of ways. So our question will never ask you to construct all of them. But can a problem ask you to construct the minimum of them or the maximum of them? So the first thing that you have to remember about this answer construction concept is that it will only be valid when there are not a lot of possibilities. Or what I mean by that is when you don't have to actually construct those lot of answers. You would be required to construct just one of them or some of them. But overall, it does not make sense to construct all of them, right? If you have to construct all of them, then DP is not required. You will not require DP if you have to construct all of them. You will just run a normal recursion and you will get all of the paths. Is that correct? Or I mean, is that clear? That in order to find out all the paths, you don't need DP. You just need a normal recursion. Okay, perfect. So one thing that I wanted to talk about is that when you are, let's say you have a state, okay. Let's say the state is dependent on 3 other states, or let's say the state is dependent on four other states, and you have to find out the minimum or maximum value. So when you're constructing the answer, should you only store the minimum of these two? I mean the minimum of these 4, or should you also store what was the choice that you made? You have a bigger subproblem, which is dependent on these smaller 4 subproblems. And you want to choose one of them so that you minimize some value. My question is, when you have to construct the actual answer, is it important to just store the value, or is it also important to store the direction that you took? The answer is that it is important to store the direction. Because if you don't store the direction, think about it. If you don't store the direction, aren't you solving the entire problem again? If I'm standing here, if I know the value, if I don't know the choice that I made, will I have to try out all 4 of them? If I know the value, even if I know the value, I will still have to try all 4 of them. Isn't that correct? So it is important to store what was the choice that you made when you were constructing that minimum answer. So what you can do is you can say that, if you have any DP state, DP, let's take another page. If you have DP of I comma j, let's say, okay, you can say that DP of I comma j, you can store a pair, right? You can store a pair which contains 2 values. First is the integer, let's say the actual value, and the second is the choice. So can I say for this grid problem, I can define my DP state as like this. DP of I comma j is something like, first of all, you have the value, and then you have the direction. The direction could be a character like D or R. Can I say that this is my state now? Instead of just the value, I also need the direction that I took. Okay, one thing that I want to know again now is this, that if I have, let's say, M choices, okay. And if let's say this is DP of I, okay. If you only store the value and you don't store the choice that you made, So when you are saying that dp of I is something like, let's say, minimum of all of these states, minimum of these 5 states, let's say, this one, this one, this one, this one, and this one. If you don't know what was the choice that you made, how will you find out what is the actual right choice? If you're standing here and if you already know the dp values, let's say, first of all, you fill up all the dp values, right? You first of all store everything. First of all, you have to store everything. And then after that, you construct the answer. So now let's say you already know the dp values. Let's say this is your bigger subproblem. It is dependent on 5 other. The value here is 10. And the value here is, let's say, 12. It is 5 here. Or sorry, it is 13 here. It is 10 here. It is 15 here. And it is 17 here. If you know that this dp value is equal to 10, do you not directly know which was the choice that you made out of these 5 choices? If this value is 10, and if I give you an equation that dp of I is equal to minimum of all of these states, if this is 10, do you not already know that this was the choice that you made? You know this, okay? But if you have these five, choices to consider, will you not have to consider all of them and then decide what was the choice that you made? How do you know that this third one is corresponding to 10? You have an array. You have to consider one of these choices, but you don't know which index would 10 lie at. So will you not have to consider all m of these? If you have m possibilities, even if I give you the value, and even if I give you the values of the lower states, you will still have to identify, right, which was the choice that you made. Do you have to identify or do you not have to identify? Do you directly know? If you don't know the direction, if you know only the values and you have m choices, will you still not have to try out all m of them? Yes or no? Will you try all m of them or will you not try all m of them to decide where does this 10 lie? If you don't know, yeah, exactly. That's the whole point. If you now have to find out, if you're standing here, if you now have to again find out which was the choice that you made, isn't it like solving the same dp problem again? How is it better now? If we have all the information, we are still not able to make a choice. Is it doing any good to us? So the answer is that by just storing the value, you still have to try out all of them. And that just defeats the entire purpose of answer construction. If you have to try out all of them again, then there is no point in talking about this answer construction thing. Yeah, that's the whole point. The thing is that when you're saying dp of I now, you define it like this. It has 2 parameters. One is the actual value, and one is the choice that you made. If you have, let's say, m choices, you can make the choices from 0 to m minus 1. If, let's say, now you store 3 here, you directly know that you made the third choice, or I mean the fourth choice in case of zero-based indexing. You don't have to consider all m of them again. So is it making sense, guys? What am I saying here? That when you're making a choice, also store it. Any doubts on this? Okay, let's do one thing. Let's solve the grid problem with this concept. So you had what? You had a function here, which will tell you the actual value int I, int j, and you have a dp. Yeah, let's have it like this: vector of int. Okay, so you need to store 2 informations. One is the actual value, and the other is the choice that you made. So you have dp of n cross. So I'm using C++ here. And the first parameter is what? How do you identify whether the state has been calculated before or not? What do you store as a value to check? Yeah, you can store a -1 since all the values are positive in the grid. And what about the direction? You can store some arbitrary value. Since this value hasn't been calculated, you can store a 0 here. So I am saying that 0 is corresponding to take a down direction. And I'm saying 1 is corresponding to take a right direction. Fine. So what do I do here? If I is equal to n and j is equal to m minus 1, what is the base case? What do I return here? I just return grid of what? N minus 1 comma m minus 1. This is the actual value. Okay, the function is returning the actual value. It is not returning the direction. It is returning the actual value. So is this part fine? That when you reach the base case, when you reach the end, you return that value that is present there. Next, what do you do? You check for memoization. You say if dp of I comma j comma first is not equal to minus 1, then you just directly return that. Okay, now what do? You take out two values. Answer 1 is f of I plus 1 comma j, and then answer 2 is f of I comma j plus 1. Now you say if answer 1 is less than answer 2, then dp of I comma j dot second, this is the choice that you made, is equal to down. So it is like 0. Else dp of I comma j dot first is dot second is equal to 1, and dp of the value remains the same. You take the minimum of both of them. And there is one more case, which is this, that if I is equal to n or j is equal to m, that means we move out of the grid, you return some very big value, 109, something like this. So tell me if this part is clear, that after doing something like this, in every state, I will also have the direction that I actually took when I do something like this. Yes or no? You consider both the possibilities, but you take the minimum of them. Okay, perfect. Let's do one thing. Let's actually, consider this, or let's have something like this. Let's have a 3x3 grid and see if it works or not. N is equal to 3, m is equal to 3, and int this is grid 3. So what I will do is I will pass an input here. And then here I will say P out f of 0, 0. So let's first of all check whether we are actually getting the right value or not. Let's say the grade is 1, 2, 3, then 1, 2, 3, and then we have 1, 1, 1. So what do you think will be the best path here? You should start from here, go here, go here, go here, and then go here, right? Is this part clear? That if you have a 3x3 grid, you should start from the top left, go here, then go here, then go here, then go here. This would be the best path in order to minimize the sum. Also here you need to add that value. Grid of I comma j. So for this type of a grid, what will be the actual value of the sum? That's the question. If you have to take the minimum path, the value would be 6, right? Let's see if you are getting 6 or not. Okay, let's see. What's the problem? I comma j dot first. Non-void function. Are you guys able to spot any errors here? The error is actually here. Okay, we're not returning it, right? We also need to return it. We can return directly from here only. Let's see if we are getting, okay, we're getting 5 actually. Yeah, so the actual value was 5 only. It was not 6. Like 1 plus 1 plus 1 plus 1 plus 1. So it was actually 5 only. Right. But do we have the path right now? Have we constructed the path? We only found out the value. Now let's talk about and let's see what was the direction that you need to take at this point. So let's try to print C out dp of 0, 0. Let's see what are we getting. dp of 0, 0 dot second. So what do you think is the right direction to take? Should we go right or should we go down when we're standing on the top left? Should we go down or should we go right? We should go down. So what do you think a dp of 0, 0 dot second should have? It should have 0 or it should have 1? Looking at this thing, it should have 0, right? Let's see if you're getting 0. Yeah, we're getting 0. Now let's try to construct this actual path. So our first point is what? Our first point is, what is the point that we're starting at? 0, 0. And where do we want to reach? We'll say while current is not equal to, while we're not reaching the end, continue to move to the next point. So what do we do here? We say if dp of current dot first current dot second is equal to 0. What do we do when dp of current dot first current dot second, this should be dot second, is equal to 0? Are we going down or are we going right? In this case, we should go down here. So we'll say current dot first plus plus. Else we say current dot second plus plus, and here we can just kind of print our current element that you're standing at. Let's see if you are going to get this answer. Okay, so what this says is that we're standing at 0, 0. Then we went to 1, 0. Then we went to 2, 0. Then we went to 2, 1. Okay, so at the end, we should also print this. So is this clear, guys? Like, what have we done here? This thing, are we getting the path or not now? Somebody saying this is a really cool trick. We need not write backtracking code at all. Yeah, were you guys writing backtracking code on your own? Like, what were you guys doing before this? If you had to construct an answer. Yeah, you don't have to backtrack and you don't have to do all of those operations again. I mean, that's the point of DP. That's the point of storing this direction or the choice. If you have m choices and if every time you have to make m choices again, then you're not using your brain. You're not using any information that you've calculated so far. So when you're constructing the answer, you should know exactly what is the answer. You should not have to make choices. Are we making choices here? In this code, are we making any choices? Or do we already know what are the choices that we made? We are not making any choices now. We already know. Right. So let's consider one more example and let's see if we're still getting the right answer. Let's say this was 2. Or let's say this was, this was, let's say 10. And this was 1. So what do you think will be the best path now? You should start from here, go to this 2, then go to this 1, then go to this 1, and then go to this 1, right? This should be the best path, or any other path. Let's try to see. Okay, so now we start from 0, 0. We go to 0, 1 here. Then we go to 1, 1 here. Then we go to 2, 1 here, and then we go to 2, 2 here. And the value was 6. So is this fine? Let me do one thing. Let me paste this code here so that you guys have something to look at later on. Okay, so is this fine? This whole concept of answer construction? Will you be able to do it on your own now if I give you a problem? Constructing the answer on your own? Of any problem actually, like not just this grid problem, but any problem. Okay, great. So I see some yeses in the chat. So I think we've covered this pretty much. Yeah. Can you also solve this problem, minimizing coins, this problem from the CSCS problem set with the same logic? If I give you, the problem as actually construct that answer. Like here, we had to find out the minimum coins to construct a sum of given value. So can you solve this problem as well with this idea, that actually constructing the answer? This was same, like you had to make some choices. You didn't have two choices, now you had m choices or n choices in particular. Fine. So let's solve one problem on this concept. And now we are also moving to non-standard problems. You will see that the problems that we're solving now are pretty new. They will not be based on some older idea. But yeah, I'll just paste this link in the chat as well, and you can read it on your own from my screen as well. Yeah, so you have an n cross m grid with non-negative integers, and you want to select one integer from each row of the matrix so that the bitwise XOR of the integers that you've selected becomes non-zero. What they're saying is this, right? If you have a grid, from every row you have to choose one integer. Let's say you chose this integer from this row, then let's say this integer from this row, then it could be again this integer from this row, then let's say this one, and let's say this one. They're saying that when you take the bitwise XOR of all of these integers, they should be non-zero. And you have to construct just one possibility. Tell us whether there is any possibility of this or not. Are you guys able to understand the problem? From every row, you have to select one integer, and at the end, you take the bitwise XOR of all of these integers. And if it comes out to be greater than zero, non-zero, then that is one valid answer. And you have to just construct one valid answer in this problem. Like if you look at this example, they have actually constructed one example, wherein they're saying that from the first row, you select the first integer, which is 7. And from the second row, you select this integer, which is 10. You select the third integer, which is 10. So the bitwise XOR is actually 13 here, which is non-zero. So that's one possibility. So tell me, is the problem statement clear? Okay, I think I've pasted the link to just one person. Let me paste it here so that all of you can see it. Is the problem statement clear to all of you, or do you need some examples or anything? And you all know what is bitwise XOR, right? Okay, great. Yeah, so think about it. What do you do in this problem? Any ideas, any states, any transitions in your mind? Okay, somebody saying recursion aa raha hai bas. What is the recursion that you're getting in your mind, like recursion concept? Try out all possibilities, right? Okay, tell me one thing. First thing is it won't try to my mind that it is DP. Can you tell me how it is DP? So again, I think you're asking the question second time. But in the next class, I will be talking exactly about how do you figure out whether it is DP or greedy. Okay? So don't worry about it. Right now, I want you to think, independently, like without even having that bias in your mind that it is a DP problem. Even if you have any greedy solutions in your mind, just speak them out loud. Okay, tell me one thing. If you're standing at this row, okay, you're standing at this row, what is the information that you need from the previous rows? Let's say this was 5 here, this was let's say 10 here, this was 7 here that you chose, this was 6 here. Tell me one thing, do you need to know what is the choice that you've made so far? Or do you only need to know what is the XOR of the elements that you've chosen so far? These are the two things that I'm asking. Do you need to know exactly what are the elements that you've chosen in the previous rows? Or do you need to know their cumulative XOR? Just their XOR. So can I define my state as something like this? TP of I comma X. Meaning, is it possible to construct a cumulative XOR of X from the first I rows? DP of I comma X is equal to, is it possible to make a XOR of X from the first I rows? Does this seem like a good state? Does this seem like a good state? Okay. If you want to construct a XOR of X, and let's say you decided to choose this element which was M, or let's say this was K, then for the previous row, what was that value that you would require to make a XOR of X? You want to make a XOR of X. The current value that you're choosing is K. So what is the value that you should have made up by the previous row in order to make X? X XOR K. If you have made X XOR K by the previous row, then if you pick up K here, then it becomes X, right? So can I say that transition would be something like this? DP of I comma X is true if DP of I minus 1 comma X XOR ARR of I comma J is true for any j from 0 to M minus 1. Or if you are taking 1 based indexing, we can say 1 to M. Can I say this? That DP of I comma X will be true if DP of I minus 1 comma X XOR ARR of I comma J, like trying out all the possibilities from the row that you have, taking their XOR with X and trying to find it out in the previous row. If that is true, then our DP of I comma X will also be true. So is this DP state fine? Is this transition fine? Yes. Can you tell the upper limit of X? Sure. The upper limit of X is 1023. Like the array elements can go up till 1023. So the XOR at max can also go up till 1023. Because 1023 is what? It is like 2 to the power something minus 1. So it has all of the bits set. So if all the bits are set in that, you cannot have a higher number than that. Right? So the limit for X is 1023. How can we come up with this transition? I mean, if you look at this, dp of I comma x, is it possible to make a XOR of x from the first I rows? Now, if you're standing at the ith row, what will you do? You have choices, right? You have m choices. So let's say you decide for this element, and this was k. So now if you had to construct x, by the previous row, you should have constructed x or k. So you look at what you, okay, 1 minute. Yeah. You look at what you want to create, and then you look at the choice that you make. And you take their combination, and that is like what you should have by the previous row. You should have made it by the previous row. If you cannot make x or k in the previous row, can you make x by XORing this k with x with any value? If you cannot make x or k in the previous row, can you make x in the current row by taking a XOR of k with some element that you could make in the previous row? Yes or no? Can you construct x if you could not construct x or k in the previous row? You cannot, right? So that's the transition here. So now is it clear? Okay, what about the base case? What if you are not considering any row? What is that one value that is only possible? Like if you're standing outside the grid, if you're standing here, what is the XOR that you can make? What is that only XOR that you can make? One more point, that we only need two states. Two states as in, like you can do space optimization. Is that what you're saying? Yeah, you only need two rows. Why? Because dp of I comma x is only dependent on the, basically the states of our current row are only dependent on the states of the previous row. So you can do space optimization, but can you see that you also have to construct the answer here? You also have to construct the final answer. So can you?
समझ गया मैं बस ये समझना चाह रहा था कि हमें सिर्फ दो ही रो लग रही हैं आंसर ओपन कंस्ट्रक्ट करने के लिए उस टाइम पे.
Yes, that's right. That's right. So if you look at this thing, I think I also mentioned this in the previous lecture. Maybe space optimization was discussed here. So not here, I think. In lecture 2. Yeah. If you look at this, I had clearly mentioned, what if we need to backtrack? Or what if the final problem requires all the states? This backtrack was for this thing only. Like if you have to backtrack and find out the actual path or actual choices that you made, you cannot do space optimization. So I've written this part, more on this in later lectures. Right. So I hope this part makes sense now. This part, that you cannot do space optimization if you have to construct the final answer. Because constructing the final answer, if you look at it, it depends on all the states. Perfect. So yeah, we were talking about this problem. And we had come up with a state, we had come up with a transition. Now, what I was talking about was the base case. What if you're standing outside the grid, like standing here? Then only dp of 0, 0 will be true. dp of 0, anything else will be false. Fine. What is the final subproblem? What do you have to check? You have to check if dp of n, any value greater than 0 is true, then answer is true. Can I say this? That once you reach the end, and if you have constructed a value that is greater than 0, then the answer is true, otherwise the answer is false. Okay, now the question is, we found out how to construct, how to check whether the answer is true or false. Have we constructed the actual answer? Have we looked at the actual choices that we made? Have we done that? We haven't done that. Why? Because in this dp state, we are only storing the value, or we are only checking whether it is possible or not. But are we checking what was the choice that we made? We did not do that. So how would you update this DP? How would you update these DP states to actually find out the answer? What would you do? At every DP of I comma x, you will have to store what was the j that you picked up. What was that choice that you made? Right? Again, use a pair. I will say DP of I dot first is this. DP of I comma x dot second is equal to choice of column that you made. Okay, so this remains same, DP of I comma x dot first. What is DP of I comma x dot second? It is that particular j for which DP of I minus 1 comma x XOR ARR of I comma j dot first is true. Is this correct? DP of I comma x dot first is the actual Boolean value, whether it is possible or not. And the second is what? It is the choice of column that you made. Yes, and we store garbage values in false, right? Yeah, it doesn't really matter. When the value is false, it doesn't really matter. What is the choice of column that you've made? Because you're not going to consider that. You're only going to consider an answer when the possibility is true. Fine. So can you see one thing, that we are going from the true state to the true state? Like if let's say DP of I comma x is true, if I'm going to some DP of I comma x XOR k, then this also has to be DP of I minus 1 comma x XOR k. This also has to be true. Can you see this? This is going to be true only when this is true. So we are saying that this is possible, then only this is possible. Look at this transition. We are saying that DP of I comma x dot first is true if DP of I minus 1 comma x or something value is true. Right, and then for the second, like for the choice that we made, we are checking any j that works. Any j that works, you store that j. So for this, like this first is true. Do we need to store some second here, like the choice that we made when we are outside the grid? When we are outside the grid, we don't have to make any choices. So is this fine? And we'll just check for dot first. Now, how will you construct the answer? Let's say I tell you DP of n comma 5 is true. How will you construct the answer? You will go to DP of n comma 5 dot second, and DP of n comma 5 dot second will tell you what? It will tell you the choice of the column that you picked up. Let's say the column that you picked up was 10th column, and the value present there was 2. So what will happen to this value now? You will go to DP of n minus 1 comma what? 5 or if you say that DP of n comma 5 dot second is true, and you realize that, DP of n comma 5 dot first is true, and you realize that DP of n comma 5 dot second is the 10th value, the 10th column. What do we do? Like if that value is 2, when we go to the previous row, we will say that the value that we want now is 5 or 2, not 5. Is it making sense? Okay, let me first of all like put this there. This is the state. This is the transition. This is the base case. This is the final subproblem. And answer construction. All you have to do is this. So you check if DP of n comma k dot first is true. You check for any of the k's that is greater than 0, and then you do this. While you have int I is equal to n and j is equal to, or let's say, yeah, XOR value is equal to k. So you say while I is not equal to 0. You start going up now. So you check, now you already know the choice. Int choice is equal to DP of I comma current XOR value dot second. What do you do? Int new XOR will be XOR value. You take its XOR with ARR of I comma choice. And or let's keep it like this. Row is equal to n. And your new row is equal to row minus 1. So after that, you update your XOR is equal to new XOR. And row is equal to new row. And you also had to, like store the choices, right? So vector int choices of the rows that you have, n comma, let's say all of them are -1. So the choice that you made here was this. So you say choices at choice, or sorry, at your row -1 actually is going to be the choice +1 because you're considering one based indexing there. So after that, you just say, just print out all of these values. So is this fine? First of all, we did some state. We had a state, we had a transition, we had a base case, then we had a final subproblem. And then when we came to the answer construction part, we are evaluating the DP states like this. We are evaluating the DP states from top to down. Now, when we have to go up, we start from here and then we start going up. We check which of these, like DP of n comma, some non-zero value is true, and we start going up now. Fine. So is this clear to all of you? Okay, let me do one thing. Let me put that there. Yeah. Ah. Okay, so are we good on this problem? Will you be able to code it on your own and submit it on Codeforces? Okay, great. So now we're done with this concept of answer construction. And I hope you understand how this is helpful and how do you, backtrack without making the choices every time. By storing the actual choice, and then when you have to backtrack, you don't actually decide for all of the choices. You directly know which is the choice that you made. Right? So can we move ahead? Any doubts? Okay, I'll wait for 10-15 seconds if you have any doubts, because now then I'll be discussing one more concept, and that will be completely different from this one. Okay, great. So now I don't see any doubt. So let's move to this another concept of representing non-integer parameters in a DP state. So let's talk about this. So up until now, you would have seen our DP states looking like this. DP of I, comma, j. What were I and j? Weren't these integers? These were always integers up until now. Or did we store anything else? Yes or no? Did you ever encounter a problem till now where I and j were not integers? Okay, we clearly didn't, right? So what if I tell you that your DP state is something like DP of some integer and then some string? So can you have a 2D array, something like this, int DP, let's say n cross m? Can you have something like this? When your DP state looks like this, that the first parameter is an integer and the second parameter is a string. Can you do this int DP of n comma m? Can you even have an array like to store this, a 2D array? The property of a 2D array is this, that I mean, obviously, if you have to have an array, the indices should be integers. The indices cannot be anything else than, and in fact, they should be positive integers. So how do you solve for this? If you have DP of some integer value and then some string here, you cannot store. You cannot store this in an array because the array indices have to be integer or positive integer. What do you do? Let's see. Use a map. Yeah, that's the answer. So up until now, we were doing something like this: int DP of n cross m, something like this. And then when we were saying DP of I comma j, we knew that I will be going from 0 to n minus 1. And similarly, j will be going from 0 to n minus 1. This we knew. But now our problem is this, that we have DP of some integer and then some string. So string is not an index. But what you can have instead is, you can have a map like this. You can have a map which has the key as a pair, the pair storing an integer, or you can have it like this, that yeah, you can have a pair. Pair's first value is an integer and the second value is a string. Okay, this is the key. This is the key of the map, and then there is the value. Can we define a DP state like this now? What were we doing up until now? We were saying that there is DP of I comma j and it has to have a value. So I and j was our key, but we could have used an array. Why were we using an array and not a map until now? Because accessing an array, accessing an element in an array is constant time. But when we talk about a map, is it constant time? Accessing this key, is it order of 1? Okay, now you will tell me that there are two types of maps. There is a normal map, and then there is an unordered map. Right. So accessing or querying in a map here is order of what? In a normal map, what is it? In a tree type of a map, what is the time complexity to search a key? It is actually log n. And for an unordered map, what is it? It is order of 1. But is it really order of 1? It is in average case order of 1, but when you're doing competitive programming, you should know that there are very smart people who make these problems. So if they want you to use a map and if they want you to get a TLE, they can construct a case wherein this unordered map gets into order of n with every key search. So I'll tell you one thing. Let's talk about this. There is a map and then there is a hash map. For map, the best time complexity is log n. The average is log n and the worst is log n. This is best, this is average, this is worst. For a hash map, the best is order of 1. The average is order of 1, but the worst case is what? The worst case is order of n. Yep. Now the problem with competitive programming particularly is that, when it comes to hash map, then people are able to construct cases where every search that you make after a certain point will result in this worst case. Why is that so? Because people who are creating these problems in competitive programming are pretty smart. Like most of them are grandmasters, international grandmasters, and they can crack these hash functions. They can crack these hash functions and give you an input wherein every search that you make now, starting from a particular point, will always result in order of n instead of order of 1. So tell me one thing, if you are using a hash map, can we assume that the actual complexity is order of n only? Should we design our algorithm thinking that it is order of 1, or should we design our algorithm thinking that it is order of n? We should design it thinking that it is order of n. And there are two things. One is CP, one is interview preparation. So you always have to remember when we talk about a hash map, in CP it is order of n, but for interview preparation it is order of 1 only. Because if you look at these lead code problems, people who've made these lead code problems aren't smart enough, I would say, and a hash map usually works there. But don't ever try to submit a problem on Codeforces with a hash map. There are very high chances that you will get a TLE, and you would not like it. So tell me one thing, would you ever use a hash map when you're submitting a problem on Codeforces? Would you ever use a hash map on Codeforces? The answer is no. Try and use a map always. 99% of the times use a map. Now there are problems which want you to use a hash map. Very, very minimal problems which want you to use a hash map. Let's say I tell you that your time complexity is coming out to be something like, you're having to perform, let's say 10 to the power 8 operations. Okay, you are performing 10 to the power 8 operations, and now you want to do a login factor here. Let's say log of 10 to the power 3. And another solution using a hash map when you have 10 to the power 8 operations, wherein you have just order of 1. So tell me, which one would you prefer in this case? This one or this one? A hash map solution or a map solution? When the number of operations that you're doing already are 10 to the power 8. 10 to the power 8 is the limit, right? So which one would you prefer? This is a map, this is a hash map. You would prefer a hash map. So like I told you, there are 99% chances that the total number of operations that you're doing are not 10 to the power 8. Okay, understand it this way. If you're doing 10 to the power 8 operations, if I add a log factor, will it give me a TLE or not? This is the first question that I have. If I'm doing 10 to the power 8 operations, and if I multiply it with a log factor, some 10 or something like 20 value, will it give me a TLE or not? So what are the chances of this giving a TLE? What are the chances? 100%. This will 100% give you a TLE. Is that right? Okay, what about this? You have 10 to the power 8, but you have some constant order of 1, which in some cases, if let's say the problem hasn't been designed in a way that a hash map fails here, then can I say with some possibility, like at least one, even if there is a 99% possibility of this failing, there is a possibility of 1% that it passes. Are you able to understand this? This one will for sure fail. 100% this will fail. But for a hash map solution, you know that even though there is a 99% chance that this will fail, there is a 1% chance that this will pass. So would you try submitting the solution on Codeforces? Yes or no? Would you try submitting this solution on Codeforces? Yes or no? If it has a chance, if it has a probability that it passes 1%. The answer is yes. You should try it if you don't have any other alternatives. Fine. But what about this case? Let's say you are having 10 to the power 7 operations and you are doing some log factor here. And now you have 10 to the power 7 and you have some order of 1 here. This is a map, this is a hash map. What will you prefer here? The first one or the second one? Tell me one thing, what are the chances that this one fails? What are the chances that this will fail? The answer is 0%. Because this is the worst case complexity. This can go up till 10 to the power 8 in worst case. So the chances of this failing are 0%. What about this? Are there some chances of this failing? Because, I mean, somebody told you that a hash map is order 1, but it is not actually order 1. If I construct a case where let's say n was going up till 1000, then this in worst case would be actually 1000. This will not be order 1. So now are you able to understand when to use a hash map and when to use a map? Yes or no? I've given you two cases. When you know the time complexity for a map is like totally fine, you should always use a map. When you know that there are certain chances, I mean, there is a 100% chance that a map fails, but there are some chances that a hash map passes, you should use a hash map. So is this concept clear? Yes or no? Although this was not DP, but this was something that was important in terms of competitive programming. Yeah, and this took me around 6 months to figure out. So yeah, now we spent only 10 minutes and you know this thing, right? Perfect. So what were we talking about? Yeah, we were talking about this concept of using a map. So if I have something like this map of pair, you have an integer and you have a string. So can I say that this type of a DP will work? Like you have this, then there is a value which is an integer, let's say, and you could use this instead of an array. Will this be fine when we have non-integer DP states? Yes or no? Yes. There is one question that I have for you, and this will be like the last question. This question that we're talking about, I will give you this as a homework. But there is one trade-off that I wanted to talk about. So there are two things that you can do. The first is map of, you have, if you talk about the key, you have these two values. You have an integer and you have a string. Okay, and there is a value. Fine. So let's say I tell you that this integer can go up till 10 to the power 6. And there are also 10 to the power, let's say 2 strings possible. Okay. So how many keys are possible in total? If there are 10 to the power 6 integers and 10 to the power 2 strings. How many keys are possible for this map? 10 to the power 8, fine. What is the time complexity to search in this map if you have 10 to the power 8 keys? Log of 10 to the power 8, right? This is the time complexity to search in this map. Fine. Let's say instead of making a DP state wherein both of the parameters are in the map, let's say one of the parameters is in an array and the other parameter is in a map. So let's say I have a integer array, and let's say this is DP, not integer array, but a map array. Let's say there is a map with string comma value, and you have these like n such maps. Okay, are you able to follow what I'm saying? Like here you were putting in both the parameters in the map itself, but here what you're doing is you're taking the first parameter and considering that as an array, and you're only putting the string in the map. Is this also fine? Are you guys able to understand what is this? Okay. Now, if there are n going up till 10 to the power 6, and this going up till 10 to the power 2, how many states do you have here? How many states do you have here? This array has 10 to the power 6 map, and each map has 10 to the power 2 values. So how many states do you have? You still have 10 to the power 8 states. Is the space complexity changing in this part and in this part? No. But what is the time complexity to search a key here? First of all, you will search for an integer. What is the time complexity to search in an array? Like not search exactly, but an array index. How would you access an array index? What is the time complexity for that? Order of 1, okay. And how would you access the string? How much time? Order of log, right? So here, the time complexity to access in the map was log of, let me write it here. It was log of 10 to the power 8. In the second case, it was log of 10 to the power 2. Which was better, the second one or the first one? The second one, okay. So this was the trade-off that I wanted to talk about. And again, this is something that is not known to a lot of people, this thing. And I can give you an example of this. Like I personally use this in one of the Google Kickstart rounds. Sorry, yeah. And you will see what I've done here. Even though it passed, but it was not the best solution that I could have done. So let's see. Where do I find this? Yeah, this one. So look at this. This is my DP actually. This map of pair of integer comma string. Are you able to see? Is this the first kind of DP or is this the second kind of DP? This one here. Is this the first kind of DP or the second kind of DP? Are we putting in both the parameters in the map or are we putting in just one parameter in the map? This is the first kind. Okay. Look at this. How am I searching in the map now? I am searching for both these parameters, the index and the string. This index and also the string. I am searching this in the map. What is the time complexity for this? I think I cannot write here, but it would be like log of the multiplication of both the states, right? So this was, when did I attempt this round? I attempted this round, I think this year itself. So up until this year, I did not know about this concept, and it has been around 3 years since I've been doing CP. Okay, I did not know about this concept up until this problem that I solved on Google Kickstart. When I submitted the problem, it did give me a right result, but after that I thought about it and I thought that this was a better solution in terms of time complexity, this one. Right? So is this correct? Like, are you guys able to understand what have we done so far in this problem? Like not exactly the problem, but how is this like an optimization and how is this the best thing that we can do when it comes to storing these DP states? So I'm not teaching you something like random stuff. I'm not saying that this is not required. I am only teaching you this because it was something that I discovered. I mean, a lot of other people might know about it, but this was something that I did not discover up until very recently. Okay, so now you know about this as well. I will give you this as a homework problem. This was from the Google Kickstart, round A 2022. And this was also the round in which I got global rank 6. So something I can boast about. But yeah, this is the problem and you have to solve it as a homework. Although we will discuss this, the first thing that we do. I mean, the first thing we will do in the next class. Fine. So yeah, that is it for this class, guys. This will be a homework. Let me put it here. And yeah, that is it. So any doubts? Okay, I don't see any doubts, but okay. Can I request you to I am not able to understand. Can I request you to Cadenay's algorithm when multiple dimensions are there? Cadenay's algorithm when multiple dimensions are there. So I'm not really sure what this problem would be about, but if you're on Discord, you can message me with the problem, and then we can like think about it. It will take some time to think about a problem completely. But yeah. Okay, in terms of this class, did you guys learn something new? And was this helpful somehow? Okay, that is good to hear. And also you had this doubt, right? That how do you differentiate between DP and 3D? So don't worry, we will be talking about this in the next class. Which rated problems to practice in DP from CF? From now you can practice like 1700, 1800 level problems as well. But I mean, let me just complete this entire series of lectures. And after that, I think you would be in a better position to tackle most of the problems, because then you would have, you would have learned almost all the concepts that are required. Then it is just a matter of thinking. How do you model the problem? Fine. So yeah, I'm ending this class now. I'm stopping the recording.